Okay, so welcome to part 2 of our lesson 7 of our PMP certification training. So once again, my name is Obalim and I'm going to be your anchor person. So if you remember, in the last session, we took a look at the various concepts that we have under project quality management. Now we're going to be taking a look at the processes that we have under project quality management. So under project quality management, there are 3 processes. And the 3 processes we have in quality are, we have the plan quality management process, we have the manage quality process, and then there's the control quality process. So when we talk about plan quality, remember earlier on we said that plan quality is where we come up with the quality metrics. So this is where we establish the quality metrics, and then also other things that we're going to be taking a look at in the course of the quality implementation of our project. That's what we do during the plan quality process. Then during the manage quality process, this is now where we perform what we refer to as our quality assurance. So basically we are making sure that everything we have in the plan quality process, that the metrics are being followed, that the processes, policies, and procedures of the organizations are being adhered to. And all of that is what we do during the manage quality process. And then the final process is now the control quality. So remember earlier on, we said that control quality is where we now ensure that our quality expectations are met in the product. So in the control quality, this is where we check the product to be sure that it meets the expectation for which was set up to accomplish. And that's basically what we do during the control quality process. So taking a look at the ITTOs, that's the inputs, the tools, and the techniques, as well as the output of each of these processes. For the plan quality process, the input would include the project charter, as well as the project management plan. Of course, don't forget that the project charter has a portion that actually addresses quality. Then the project management plan will be an input here, because after we finish planning quality, we need to integrate it into the project management plan. So that's why we need the project management plan as an input in the plan quality process. Then also you need other project documents that will enable you to effectively determine the metrics with which you're going to be able to measure your project performance. Then also you talk about the enterprise environmental factors. So this is where you put into consideration factors that are not within your control. And then also what we refer to as the organizational process assets. So the organizational process assets is anything of value that can aid you in planning your quality. So part of the tools and techniques to plan quality would include expert judgment. So of course, don't forget, this is where we seek the opinion of a subject matter expert. Then also we'll talk about data gathering, data analysis, as well as data representation. So in other words, to enable us to plan quality, we need to gather relevant data and then analyze those data, and then of course specify and model them. That is, represent them in the best possible way for ease of understanding. Also, we also need decision-making techniques to be able to decide on the relevant policies, metrics, and then also standards upon which we're going to base our quality implementation and expectation on. Also, test and inspection planning. So this is basically where you create a plan as to how you're going to carry out test and inspection in the course of the project implementation, and that's what your test and inspection planning focuses on. And then also meeting is also another technique you can actually adopt when you're planning your quality. So the output of this process will be our quality management plan. If you remember, we said anytime you plan any knowledge area, the output will be the management plan of that knowledge area. So after we plan quality, the output is now the quality management plan, which of course will address how we're going to go about our quality procedures, the test and evaluation procedures, and then also how we're going to ensure quality throughout the implementation of our project. Then also your quality metrics. Remember, we talked about quality metrics earlier on. So this is basically the standard that the project would accomplish. And then also we now update project management plan as well as any documents that might need to be updated. So these are some of the outputs that we get after the plan quality process. So let's refer to the student workbook. It says complete one of the project requirements. Use the example provided as a guide. So after we plan quality, the next process is now the manage quality process. So here we state that the manage quality is the process of translating the quality management plan into executable quality objectives, into executable quality activities that incorporate the organization's quality policies into the project. So it is part of the executing process group. So like I mentioned earlier on, the managed quality is basically where the action begins. So we begin to act on all of those things that we have in the quality management plan, making sure that the principles are being followed, the metrics as well as the plan that we created earlier on in the previous process, that they are being adhered to. So the inputs to manage quality would include our project management plan, as well as our other project documents, and then also the organizational process assets. So these are the inputs that we need to manage quality. So part of the tools and techniques to manage quality would include, of course, we also need data gathering, analysis, as well as representation. So to enable us to manage quality, we need to be able to gather data as to work performance, and then analyze the data by taking a look at the difference between the performance, which is the actual, against the plan as captured in the quality management plan. And then be able to specify and model the data, in other words, represent it in an understandable manner to enable us effectively communicate it. Then also decision making is also part of the tools and techniques to manage quality. So decision making in this regards talks about the fact that sometimes when it comes to, managing quality, we need to take decisions based on the outcome of our analysis. Then also we carry out quality audits. Audit is also a way to enable us manage quality. Of course, audit has to do with reviews, inspections, and then also being able to determine conformance to a agreed set of standards. So this quality audit would now enable us to be able to determine if we are actually carrying out our project as, contained in the quality management plan. And then also we have what we call design for experiment. So design for experiment is basically where we come up with what we refer to as sample designs for the purpose of experiment. That's why it's called design for experiment. So these sample designs will enable us to effectively determine how the final product would look like or behave in the event we carry out the final product. So part of the reason why doing the design for experiment is necessary is because we may not have the wherewithal to spend all the money in the final product. So that's why it is necessary you create like a DOE, that design for experiment, and then based on that, you will now be able to make final decisions. Then also you need problem solving skills, because in the course of managing quality, when you review your processes and you discover that there are inconsistencies or problems in your processes, then of course your problem management skill now needs to come in there to be able to help you to effectively resolve that. And then also you have your quality improvement method. So quality improvement method basically takes a look at various ways you can consistently enhance your quality, and that's exactly what the quality improvement method here refers to. So the output would be your quality reports. So when we talk about quality reports here refers to the outcome that we get after we manage our quality. And then also you have our test and evaluation documents. So test and evaluation documents are now documents that enables us to effectively keep track or keep record of all the results that we gathered in the course of the managed quality process. For example, in the course of the quality audit or inspection. Then we can also do a change request if the need arises. And then don't forget that if we do a change request, maybe because of the fact that we notice that there are certain things that need to be modified in this project in order to enable us to constantly meet the quality expectation, then we may now need to go back and update the documents, including the project management plan and any other project document that may be affected. So the final process is what we now refer to as the control quality process. So this is the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. So it is part of the monitoring and controlling process group. So the control quality basically is where we now track our product and then be able to ensure that our product meets our expectations. That's what we refer to as the control quality process. So of course the input would include what we refer to as our deliverables. So don't forget that these deliverables are deliverables that are generated during the direct and managed project work. And this is essentially where you come up with these deliverables. And if you remember back then, I mentioned that the deliverables, which is the output of the direct and managed project work, we now need to go through what we refer to as a control quality process. In other words, this is where we check those deliverables, those products, outcomes, to be able to determine that they meet quality expectations. And then based on that, we now do what we refer to as scope validation, which of course we discussed under project scope management. So that's why you're seeing deliverables here as part of the input in the control quality process. Then also your work performance data. So don't forget that your work performance data is what you're going to be comparing with the deliverables. The work performance data here refers to all the data that you've gathered in the course of this implementation. That's what the work performance data refers to. And this is what you're going to be comparing with the deliverables. And then you also need the project management plan as an input during the control quality process, because the quality management plan will already be integrated into the project management plan, and it has already stipulated how you're going to carry out the process of the control quality. And then also we have what we refer to as approved change request. So approved change request simply refers to changes that have also been requested for that has actually been approved after they've gone through the perform integrated change control process. So they also form input in the control quality process because you use it to be able to determine how well has the change been implemented and have we met the expectation or quality expectations that the change is expected to deliver. And then also other project documents. Don't also forget that the organizational process assets as well as enterprise environmental factors will also form input in the control quality process. So part of the tools and techniques, of course, would include the quality metrics, which of course we determine when we plan quality. And then aside from that, you also have your quality checklist, which is also part of what we determine when we plan quality. So all of these are part of the things that would, serve as tools and techniques to enable us control quality. And then also, so other tools and techniques would include our data gathering, data analysis, as well as data representation skills. Of course, you should know what this means already, because when we're going to be controlling quality, we need to gather data about the final product and its performance, then analyze it by comparing it with, the metrics, and then, of course, represent it in a readable as well as well understandable format. Other ways we can carry out quality control can include via inspection, as well as testing and product evaluation. And then also we have what we now refer to as meetings. So meetings is also a very important tool that we can actually adopt to enable us control quality. So the output of this would be our quality control measurements. So the quality control measurements here are basically the results that we gather after we have gone through our checklist to be able to determine how well the product meets quality requirements. And then also, after we have gone through the control quality process, the deliverables, which of course are part of the things we check during the control quality, they now become verified deliverables. So verified deliverables simply means that we have checked these deliverables and then they meet quality expectations, and then they can now be used for further project work. And then you have your work performance information also as an output of this process. So work performance information simply refers to the information that we have gotten based on the fact that we have done this analysis, which is our data analysis, which will help us to be able to determine whether we are meeting quality expectations or we have a variance with regards to the quality expectations. So those work performance information can now, of course, trigger what we refer to as change requests, especially if there are variances. And remember, like we mentioned, the change request will help us to address any abnormality. And then if the change request is approved, it may now warrant us to update documents that the change may affect, including our project management plan, as well as other project documents. So let's take a look at this business scenario and you tell me what you make out of it. You are a project manager with Ace Engineering Inc. 4 months ago, you wrapped up a project that produced an ignition switch for an automotive company's ignition switch redesign. Managing the project went well because your parts consistently met your quality metrics and fitness for use tests and passed all control charts. There was no indication of issues with quality and grade that would prompt a need for change. During a post-production quality audit, one of your company's test engineers discovers that a key chain with many keys could pull the key out of the ignition, causing a car to stall as it is driving. This could potentially cause serious injury as airbags would not deploy in an accident. Several 100,000 cars have been sold with the ignition switch manufactured by the automotive company. What should you do? So in this case, we're asking basically what would you do in this regards based on this particular problem statement. So one of the things you can actually do is to do, of course, root cause analysis to be able to determine what gave rise to this. And then after you've done the root cause analysis, you may now want to implement corrective actions, either by doing a recall of those vehicles to fix the ignition switch, or you can also set up service centers at different locations where the owners or people who have bought those vehicles can actually take their cars to and then be able to do what we refer to as a repair, as the case may be. So these are some of the measures that you can actually take to enable you to fix this problem. So finally, we're going to talk about what we now refer to as the 7 basic quality tools. So the 7 basic quality tools includes: 1, we have what we call our control chart. So there's a control chart. We also have the check sheets. Then there's the scatter diagram. There's the Pareto diagram. Then we have the histogram. There's also the flow chart. And then also we have what we refer to as the cause and effect diagram. So these are the components or the things that make up the 7 basic quality tools. So interpret the 7 basic quality tools as the tools that can actually be used in order to enable us to effectively carry out our quality management processes. So we shall take a look at the tools one after the other. First of all, let's talk about the control chart. Control chart helps us to determine if a process is within what we refer to as acceptable limit. So what we mean by that is the fact that we want to be able to determine what we refer to as our acceptable deviation. So let's say, for example, we're into the manufacture of plastic chairs, and we have a measurement for our plastic chairs that the thickness of our plastic chairs at every point in time should be at least 5 mm. So at the end of the day, in the course of the manufacturing, don't forget 5 mm is the expected. So that's the mean. So this is essentially what we're expecting to get. That's the 5 mm. But then we now set up what we refer to as an acceptable deviation, which is now, if it is not, what we're simply saying is, if the measurement is not exactly 5 mm, is there a range that is still acceptable? So we can simply say, okay, 5.5 is still acceptable. And then also 4.5 is also quite acceptable. So this range between the 5.5 to 4.5 is what we refer to as our acceptable limit. So any chair which comes out of our manufacturing line that we measure and the thickness falls within this range would be passed as part of our acceptable, as part of the chair that is acceptable. So the upper part of your control chart is known as your upper control limit, and then the lower part is now known as your lower control limit. Don't forget, this median or this middle part is known as your mean, which is typically what we expect to accomplish. So, like I mentioned earlier on, any result within this control limit is acceptable, and that's exactly what the control chart does for us. However, we now have cases or situations where you need to worry, and the cases or situations where you need to worry are: 1, when you begin to get results that are outside of your control limit. That is one particular scenario. See, for example, the chairs we're now making are, you have 4.3, you have 4.4, you have 4.1, you have 4.2. So these results are outside the control threshold, or they are as thick as 5.7, 5.8, 5.6, and on and on and on. So of course, when you get results outside of your control threshold, these are the products that you're going to classify as products that have defects. Now, aside from that also, we have what we refer to as the rule of 7. So rule of 7 simply means if on 7 consecutive occasions, the results you get fall within a particular threshold, either above your mean and below your upper control limit, or below your mean but above your lower control limit on 7 consecutive occasions, that's what we refer to as rule of 7. So you also know that you have a problem if the rule of 7 occurs. So let's say the first chair that comes out was 5.1, and then the other one was 5.2, then the third one 5.1, the fourth one 5.3, the fifth one 5.4, the sixth one 5.2, and then the seventh one 5.3. So this is what we refer to as rule of 7. So you can see 7 consecutive chairs that came out of our manufacturing line, all were above our mean, but then below our upper control limit. So we now know that there's a problem. So the problem could be that, one, our machine has readjusted and is not reading 5 mm as the thickness. So maybe it's now reading maybe 5.25 as the thickness, and that's why the results are oscillating here. And then also don't forget, it also means that we are spending more money because a lot more material is now going into this, which of course, if you take a look at what we talked about, what we refer to as optimal cost of quality, it might mean that, of course, any additional cost or resources that has gone into this particular product does not in any way translate into an increased return on investment. Don't also forget that your rule of 7 can also happen below your mean and above your lower control limit. So what we're simply saying is you can also have the rule of 7 in this stage. So you have the first year, which is 4.7, then you have 4.8, the third one comes out, it was 4.6, the fifth one comes out, it was 4.7, the sixth one comes out, it was 4.9, and then the seventh one comes out, it was 4.6. So this is also another rule of 7. So this rule of 7, like, is stipulated here, is also another major concern, as the case may be. So from this instance, or from this example that we have here, if you notice, most of the products that most of the chairs that came out of our manufacturing line, none was up to the 5 mm, which is of course our standard. It simply means that we also have a problem. That's also another situation where we can apply the rule of 7. So what this means is that we have inferior chairs. In other words, our chairs actually do not meet the standard or the quality expectation that we actually publish. So this is essentially what the rule of 7 here refers to. Now, aside from that, the second aspect of the 7 basic quality tools is the cause and effect diagram. So cause and effect diagram is also known as the Ishikawa or fishbone diagram. So the cause and effect diagram is used to do what we refer to as root cause analysis. So it helps us to be able to determine the root cause of a problem or a quality problem that we may have in our project. So for example, we have a problem with excessive downtime. So typically for the cause and effect diagram, you begin by drawing a rectangular box, which of course will represent the problem. So in this case, the excessive downtime is the problem. And then you now put them into what we refer to as the M's and P, which of course would include into what we refer to as the 4 M's, which of course would include machine, measurement, material, as well as man. Of course, don't forget that man is now replaced by people. So when we've now been able to now determine these 4 M's as the case may be, or 3 M and a P, then we now begin to look at various aspects of these M's that could actually give rise to this problem or effect that we are looking at determining the root causes. So for example, under measurement, we may begin to talk about, could it be that we don't track the uptime, or could it be that we have poor downtime definition? Then under material, could it be that our product is out of specification? And then also under people, could it be that our resources are poorly trained, or they have a don't care attitude? And then under the machine, could it be that we don't have a project management program, or that our equipment are old and exhausted, or that we have issues with funds? All of these are part of the things that can actually help us to do a diagnosis and be able to determine what the root cause of this our problem is. So don't forget that the cause and effect diagram is basically used to carry out root cause analysis. Then we also have the flow chart. Flow chart basically is a graphical representation that shows how a process or system flows from beginning to the end and how the elements interrelate. And that's what the flow chart does. So basically it shows you how processes flow from start to finish. So let's say, for example, we want to represent processes that is involved with regards to how we deliver our particular output to customer. So of course, we might now indicate it using what we call a flow chart. So of course, they represent the process and help analyze where the problems occur. And then they are also used to identify redundancies as well as bottlenecks. So for us to be able to carry out the process of our supply, we need to first of all get input from our suppliers, and then it now goes through our own transformation process, and then of course to giving us an output, which is now what is now gotten across to the customers. Aside from the flow chart, there's also the histogram. So histogram is basically a vertical bar chart. That's what the histogram shows. So it shows us the frequency of occurrence of a particular variable, and the height of each column represents the relative frequency of that variable. So the histogram basically shows us, is more like a data representation tool that shows us frequency of occurrence. And that's one key thing that the histogram shows us. So it helps us to represent data, so that by taking a look at the histogram, you could already begin to tell where, majority of your problem lies, and then also where you have the highest frequency, as it were. Aside from that, we also have the Pareto diagram. Pareto diagram is also known as the 80-20 principle. And then, of course, the 80-20 principle is predicated on the fact that 80% of the problems we'll have in our project will be due to 20% of causative factors. So what the Pareto is actually talking about is the fact that instead of we taking a look at all the various issues or problems we have in our project, so what the Pareto diagram is simply saying is that instead of we taking a look at all the various causative effects that may be giving rise to the problems we have in our project, we can simply take a look at the causative effect, that's the 20% causative effect that is giving rise to 80% of the problems we have in our project. And in this case, you have our holes as well as spore mix. So once we're able to fix that, it addresses 80% of the problems that we have in our project, and that's essentially what the Pareto diagram helps us to accomplish. Then we also have the check sheet. Check sheet is basically more like a checklist that is used for data collection. This is particularly necessary, especially when you want to carry out inspection, maybe during a quality control process. So of course, in the check sheet, you itemize what we refer to as the various descriptions, which we refer to as the defect descriptions, and then you now itemize, or you indicate using a check in any process at all where this particular defect may occur. And then of course the sum total is now put at the right hand side. This is essentially what a check sheet is for. So remember, we said the check sheet is used for data gathering, and then also it's also a very important tool we can use, especially when it comes to inspection. Then we also have the scatter diagram. So scatter diagram helps us to track if there are relationships between two variables. That's one key thing that scatter diagram helps us to do. So it helps us to determine whether there are track two variables to see if they are correlated or they have no relationship. So if the two variables are related, scatter diagrams are used to observe the changes in one variable due to a change in the other variable. So for example, remember we're giving an example of our plastic chairs, and we noticed that most of the plastic chairs were not falling within the 5 mm control threshold. So we now want to determine what could be giving rise to this. And we now choose various variables. We want to measure if there's a relationship between the grade of the raw material that we use as well as the thickness of our chairs. So we may discover that at the end of the day, there is a positive correlation. Positive correlation in the sense that the higher the grade of our raw materials, the higher the thickness, as it were. So we know that there is a relationship between the grade of our raw material as well as the thickness. Then if we now decide to plot other variables, say for example, we want to determine if there's a relationship between the personnel as well as the thickness of our raw material. So we vary the personnel and bring in different operators to run the machine to be able to determine what might be the outcome using the same metrics, as it were. So at the end of that, we may discover that there is no correlation. In other words, all the personnel got the same result whenever we vary the metrics, as the case may be. So we can see that there is no correlation, as it were. So that's one key thing that the scatter diagram helps us to accomplish. Like I said, it's basically a tool that helps us to determine if there's a relationship between dependent as well as independent variables. So here, we took a look at the processes that we have under project quality management, 3 processes, which are we plan quality, we manage quality, and then we control quality. And then finally, we took a look at the 7 basic quality tools. And the 7 basic quality tools are, first, we talked about the control chart. So the control chart, like I mentioned, helps us to determine what to refer to as acceptable deviation. And then we have the scatter diagram, which helps us to determine if there's a relationship between variables. We have the histogram, which is a data representation technique that shows us concentration. Then there's a Pareto diagram. Pareto diagram helps us to prioritize and know where to focus our efforts on. And then we also have the check sheet, which is a data gathering technique that we use to be able to gather data. We also have the flow chart, which shows us sequence of events or processes within our project. And then finally, we have the Ishikawa, or the cause and effect diagram, which is a tool that we use to perform root cause analysis in our project. I hope this particular lesson has been very informative for you. Once again, I want to thank you for listening and see you in the next lesson, which is project resource management.